I'm Adrian Kent from Cambridge and sometimes also from Perimeter Institute. I just want to make a very simple point about Bell experiments and quantum collapse models that seems to be underappreciated and that is at least a little bit relevant to some of the discussions we've already had and to some of the talks tomorrow at this meeting. So I'm going to focus on the most relevant example, which is Wigner's hypothesis that collapse depends on conscious observation. So that said, what I'm going to say applies to any hypothesis in which collapses are objective and localized. So here's a sort of schematic description of a Bell experiment. You have a source of entanglement. The entangled particles go to detectors. The detectors have settings and produce outcomes which are propagated by some channel that might be a little wire to something larger or more definite, a fixed apparatus that records the results. And eventually, these are brought together in some sort of correlator. And the point is, if you believe or assign non-zero weight to a collapse hypothesis which says that wave function collapses are objective and localized, then you should be dissatisfied by essentially every implementation of Bell experiments to date. Why should you be dissatisfied? Because the point of a Bell experiment, of course, is to demonstrate Bell non-local correlations of measurement outcomes. And if you're adopting a localized collapse hypothesis, it's that hypothesis that tells you when and where the measurement outcomes actually take place. And you need something that's appropriately large or appropriately conscious, the apparatus here, to be generating those outcomes in space-like separated regions. So you need, at the very least, that these red regions on the left and on the right are space-like separated. If you want to think of the apparatus here as a human consciously observing the outcome, and the apparatus here as a human consciously observing the outcome here, then they need to complete their conscious observations in space-like separated regions. If your aim is to prove that you have Bell non-locality of measurement outcomes. That hasn't happened in any Bell experiment to date. People have thought about doing Bell experiments with human observers, but I think they haven't appreciated that these experiments actually don't need long-range entanglement, even if your aim is to achieve the ideal I described before. All you need is a conventional Bell experiment involving entanglement somewhere here, a communication channel here to a human, which by hypothesis doesn't cause collapse during the communication channel, and another communication channel here to another human. And given our perception times, we need quite a large separation, larger than the diameter of the Earth. So one of the humans has to be in space, but the other one doesn't. Probably most people, I think the chances are small that we will get a surprising result. I've been taking bets at odds of 10,000 to 1. In other words, you pay me 10,000 if the outcome is surprising, and I pay you 1 if the outcome is not surprising, for units of currency of order 1 or smaller. And I'd be happy to take a few more. I think I'm willing to risk that. The chances of a surprising result are small, but the payoff would be huge, both in understanding quantum theory and in giving us a direct test of consciousness. So we certainly should get these experiments done in the reasonably near future. And that's really all I wanted to say. Thanks very much.